Hello everyone, I am Dr. Somjit Biswas. I am an associate professor in Department of Metallurgical and Materials Engineering, Indian Institute of Technology, Kharagpur. I am going to introduce you to the course Texture in Materials. So, this is the very basic introduction to this course. You see, materials such as polycrystalline materials, which are basically minerals, metals, ceramics, semiconductors or superconductors, are made up of many small crystals. So, they are made up of aggregate of many crystals. The processing of these materials in order to obtain certain properties are usually in metallurgy is described in terms of a material tetrahedron, which gives the relationship between processing microstructure property and thereby the processing methodologies such as solidification, phase transformation, plastic deformation or recrystallization techniques are used to design and develop a certain kind of microstructure, a desired microstructure, which should include the information of the crystallographic orientation, which is basically known as texture or crystallographic texture. A combination of these microstructural features leads to obtain desirable mechanical, electrical, magnetic, semiconductor properties. It also may give surface engineering properties such as corrosion properties or tribological properties of the material, and therefore, based upon the required performance, the material is designed. Polycrystalline materials are basically crystalline in nature. Therefore, most properties are sensitive to anisotropy. Crystal alignment and the associated anisotropy is usually ignored in classical metallurgy. Microstructure should include crystallographic orientation, that is texture. The objective of this course is to provide the tool to understand and quantify various kinds of texture to solve problems that involve texture and anisotropy. The outcome will be to develop an understanding of texture, to acquire knowledge in microstructure and texture engineering, to produce structural components for bioimplant, aerospace, automobile applications, as well as in magnetic, electrical, semiconductor materials, surface engineering, coatings, corrosion and tribology. The people who will be benefited from this course will be the ones who are doing Bachelors of Engineering Technology, Masters of Engineering of Technology, PhD in Metallurgy, Material Science and Engineering, Mechanical, Applied Mechanics. Professionals who are working in steel, metal forming, automobile, aerospace, biomaterial industries and R&D professionals, scientists, researchers, R&D professionals in national defense, space, metallurgical laboratories such as BARC, Bombay, IGCAR Kalpakkam, DMRL Hyderabad, ISRO Thiruvananthapuram. The outline of this course will be divided into 6 parts. The first is introduction. So, I will introduce you to the concept of texture. There we will be learning basic crystallographic, basics of X-ray diffraction, introduction to the pole figure. Then in the second chapter we will be doing characterization of the texture, including macro and micro texture analysis and measurement, measurements of macro texture using X-ray methods, the limitation of X-ray method for texture measurement, measurement of microstructure and micro texture using SEM EBSD and their application. 3-dimensional texture analysis will be done in the third chapter. Here we will describe the crystallographic orientation with respect to the specimen axis, that is the important sample reference axis, and we will describe mathematically the texture in terms of pole figure, inverse pole figure, orientation distribution function, Euler space, orientation matrices and Miller indices. Fourth, grain boundary engineering. Here we will classify the types of grain boundaries, which will include geometrically necessary boundaries that are low angle boundaries and the grain boundaries which are high angle boundaries, coincident site lattice boundaries which are special boundaries with low energies, and then we will go to grain boundary character and energy classifications. Finally, on the fifth chapter we will be learning texture development during solidification and phase transformation techniques, and in the sixth chapter we will be doing texture development during plastic deformation. So, we will understand the deformation mechanism, we will understand the texture that can develop in face centered cubic material, hexagonal close packed material, body centered cubic materials. We will understand the theory of polycrystalline deformation, the texture development during dynamic and static recrystallization. The references that will be used in this course are: first, Introduction to Texture Analysis by Valerie Randall and Olaf Engler, Crystallographic Texture of Materials by Satyam Suhas and Ranjit Kumar Ray, Recrystallization and Related Phenomena by Humphrey and Hatherley. One should also look into two basic books which are very important for this course, that is Physical Metallurgical Principles by Reed Hill and Elements of X-ray Diffraction by Kaliti and Stock. Thank you.